Okay, so here we are at the solution for Gematria. Let's talk about how I chose to do this. Of course, this is just a solution. You may have chosen to do it slightly differently, and that's totally fine. So I'm going to go here to my program, and one of the things I know I'm going to need is I'm going to need to import RE because I'm going to be using the RE module. First thing I want to do is to fix this word denom so that it passes this test. To me, it's good to focus on the smallest possible problem and write a function and the test for that function, and then you can use that function in a greater context. You can compose it into larger. You can compose all these smaller functions into larger programs, and I think that's a much easier way to go about writing a program. So the first thing I know I need to do is I'm going to re sub, and I'm going to write that a to z 0 to 9 that we talked about, and I'm writing that as a character class, and then I'm complementing it with the caret so that it will use the reverse, the complement of those characters. So anything that's not a to z 0 to 9, that's what's going to be substituted, and the value that's going to be substituted is the empty string, and I'm doing that into Word. I'm applying this to the word. So as we saw in the introduction, the word don't with the apostrophe will return just the characters DONT. That's how I'm going to clean up the word. And then I need to apply the ordinal function to each one of the resulting word. So re sub is going to give me back a string. So I can, for instance, I could do the ord function on the char for char in that. That is one way to write this as a regular as a list comprehension, and that is going to give me back a list of integer values, which I can then call sum on, and then finally I need to return the string representation of that, and so I'm going to say return string. I'm pretty sure that should, I don't want to run the ASCII table, I want to run the PyTest. That is actually how to write word to num, combining all those things that we talked about. So going back to substituting, using this regular expression, using these character ranges that now we've exhaustively talked about. I hope you really understand why a to z 0 to 9, why we have to do those as 3 separate ranges. So we're going to substitute any of the characters that is not found in those ranges. We're going to substitute the empty string. That's going to return a new string, which we can then iterate over for character in that string, and then we're going to call the ordinal function on that character, and then that's going to produce a list of integer values for all the characters in that word, which we're going to sum and then return a string representation. A slightly easier way to write this would be to map. Turn this. Actually, let me leave it as that so that we can compare. I'm going to write it. I'll just copy and paste this real quick. Let me comment that out for a moment. I prefer map, so I can get rid of all of this this business. And let's see, I'm going to need to get rid of that, I think. Let's see, how many have I gotten them all? Well, I guess there's, I always have a hard time with the parentheses. It looks like I got the right number. So this is a shorter way to write this, extremely concise. I know it's maybe seems like overkill to write a function that is really just one line of code, but there's so much that you get from doing that. You've given this this idea, you've given it a name, word to num, and then you've given it a test. You've abstracted that out into this function that you can call from other places in your code. And it's going to make it a lot easier to integrate this into a greater function. And of course, not this particular function. This is not an incredibly useful function, but think as you write larger programs, you're going to come up with really cool functions that you might want to use all over the place in your code. If you, rather than copying, pasting that one line that is so darn useful, you're going to put that into a module, You're going to put that into a function in a module that you can then share amongst all of your different programs. And you're going to write tests for that function. And then if you ever find that that function needs to be expanded in some way, you'll change it in the one place rather than trying to remember all the different places you copy and pasted that idea around and fixing it in all those places. It's much better to write functions and tests and put them in modules and share them. That's why Python works as well as it does. That's why so many programming languages work this way, is because we build on other people's code or our own code, and we test that code. And so that's how the world moves forward, is by writing code like this. Okay, so we have now this abstracted this word to num, and now let's use it. And so rather than than printing this like that, we're going to go back to this idea for line in argtext split lines, because we want to maintain the line structure. And what we want to do is call line.split, right? That's going to split the line on white space. And what we want to do is, I'm just going to jump straight ahead to using map. I want to map onto my word to num function the result of splitting the line. And that's going to give me back a list of words that have been encoded, which I then need to join back together on the empty string. And then I need to print that. I'm pretty sure that's going to work. Let's run it on foobar baz. That looks okay. Let's run it on our inputs fox. That looks pretty good. Let's run it on the spiders that has multiple lines. You see how it gave us 3 lines of output. This looks pretty good. How do we know it's right? Let's run our test suite. Let's see how that passes all of the tests that I wrote. So this ends up being really a very short program that does something that's pretty powerful. It actually incorporates a lot of really interesting ideas, and because we're building upon all of these really well-tested ideas like mapping and summing and reducing and regular expressions, and because we wrote a function word to num that we abstracted out and we tested and we know that works, we can just join all these pieces together to create very brief but incredibly powerful programs. I think this is while trivial, really a lot of fun to write. Let's see if there's anything up here, anything else. Oh, I go into other ways of writing this. If I wanted to write this as a for loop, which I think is much worse, I could have written it with a list comprehension. But I think that the map version is just a little bit easier to read. Here I show you how these bits here in the for loop and the list comprehension, how they all, how you can see all the different pieces are still in place. It's just that the map ends up being really the shortest and I think cleanest way. If you want to really think about how the data moves through all of this, then resub is going to take this word don't, and it's going to return a new string don't. I want to map that into the ord function, and so that's just like saying ord d, ord o, ord n, ord t, and that's going to create a new list. Those are each going to be processed, and then it's going to return the ordinal values for each one of these, 68, 111, all that. The sum is going to return that, reduce that to 405, and then the string function is going to turn that into the characters 405. So that is how my solution works. I think that there's a section here where I talk about sorting, and if I take, for instance, these words banana, apple, cherry, anchovies, cabbage, beets, if I call sorted in Python, apple, beets, and cherry sort before anchovies, banana, cabbage. The reason is because of the ASCII table, because the uppercase characters are defined with a lower ordinal value than the lowercase ones. And so if we want a case-insensitive sorting, we have to be very specific about that. And we can call here, there's a key option to sorted. and we could pass it a function that will be applied to all of the words before they're sorted. So that should really ring a bell. It's a higher order function, right? It's a function that takes as an argument another function, and it's applying this string casefold function to all the values, and then you see anchovies and apple sort, banana and beet sort together, and then cabbage and cherry. So that is a case insensitive sort, which is not the same as what you'll get from the default value, the default behavior of sorted in Python. And now that you really hopefully understand the ASCII table and all of this, all this business, you really understand why you need to pass in this string casefold function, and hopefully you also really understand that it's a higher order function. The note here that when you can use the same key a value if you're going to do an in-place sort on the list. So if you say words.sort, you can also pass key equals string casefold, and now words has been sorted in place into a case insensitive sorting. But the string casefold was only used to decide where to put the values. The values themselves still remain lowercase and uppercase. So really, to me, quite fascinating. I think that's really interesting. Note that often it is the case with the command line tools, like there is a sort program that we can use on the command line, and if I put those same words into a text file called words.txt, and on my Mac, if I call sort, I'm going to see the same behavior that I saw from Python. It's going to sort the uppercase characters before the lowercase. I have to actually look at the man page and find that there's a -F flag that will do a case insensitive sorting. It's not the case, I think it's on my Linux, on a Linux machine, the default behavior of sort is to be case insensitive. So you have to look at what version you have. I don't know what it would be like on Windows. It would be interesting to look at. The last thing that I just can't stress enough about testing is that I use my own tests over and over again as I've been writing these programs for you. So I wouldn't have the confidence to show these to you if I didn't have my tests and if I didn't use them religiously. So I hope that you are really coming around to the idea of writing and using tests. Our review is that the ordinal function returns the ordinal value of a character. We've been talking about the ASCII table, but there's far more characters in the universe, in our written languages, than just the English characters, of course. The char function will take a character and give you back its position in the ASCII table, or it's just its ordinal position. Those basically go back and forth. We use character ranges like A to Z and regular expressions because those characters lie contiguously in their ordinal values. So you can't use character ranges if the characters don't lie contiguously. Keep that in mind. The RE sub function, we use that to find any pattern of text matching a given pattern and then replace that with something else. The map, we've seen how we can use map without writing a lambda function if a character if a function expects exactly one argument. And we saw the same thing about reduce. Reduce expects a function that accepts 2 arguments. So we, instead of writing a lambda with reduce, we saw how we could use the operator mul function. And then finally, we talked about case insensitive sorting with the sort and sorted functions by using the key equals string casefold option. That's a function that's out of the string class. So some ideas for going further. I thought that was really fascinating. I hope you did too. Thanks very much.